truth tables. So last class we talked about fallacies, right? And fallacies were bad arguments. Arguments dealt with, you started with a premise and followed by a conclusion. Today we're going to talk about propositions. Propositions are just statements. I'm going to just do some definitions for you guys first. It's a claim that may be either true or false. A claim that may be either true or false. Okay, so a proposition is just a statement. It could be either true or false, but one other thing, it must be a complete sentence. So I'm going to put here, not a question. It needs to be the structure of a complete sentence, not a question. So again, a proposition is just a statement. It's a claim. It can be true or false, but it needs to be a full, complete sentence, not a question. And then we have another term, truth values. Truth values are the value I'm going to assign to a proposition. So the only truth values we have are true or false. So I'm going to write here, any proposition has two possibilities. True or false. And when I say true or false, I'm going to put T for true or F for false. The truth table, that's what we're going to end up doing today. We're going to construct truth tables. I'm just going to define it like this, and we'll go into detail on it later on. But it's a table with all the possible truth values for a proposition. So a table with all possible truth values for a proposition. And then the last thing before we kind of go over some stuff, logical connectives. So sometimes you have more than one proposition. Again, a proposition is just a statement, right? A sentence. We don't care. It could be true or false. If I have more than one proposition, I'm going to connect it with words like and or if and then. Those are called logical connectives. They just connect propositions together. So they're words like and, or, if, then. And these are words that connect or join propositions together. So I'm just going to say they join propositions together. So now let's look at an example. Let's look at these 6. It says, is this a proposition? So the first one says the door is closed. If it's true or false right now, a proposition is just a statement, a simple statement. The door is closed. Yes. What about the next one? What time is it? This is not a proposition, it's a question. I'm just going to highlight the question mark. That's not a complete statement or sentence. C, is it rain? I'm sorry, it is raining and it is cold. Yes, that is a complete sentence. Today is not Wednesday. That is a complete sentence. Again, we don't care if it's true or false. A proposition is just a statement. Next, he is president. We don't have more context to that. It's not very specific, but he is president is a complete sentence. And then the last one, if today is Wednesday, then the sun will rise. This is actually that if then statement that we talked about. It's connecting two propositions. The first one is today is Wednesday, and then the other one is the sun will rise. It's being connected by an if then. So this is a yes. Okay. Let's talk about negation. So the symbol for negation is that squiggly line, just like that. Looks like this, just a squiggly line. Negation. Negation literally means not. So it's actually also sometimes considered the opposite. So if I have a proposition P, the negation would be the opposite of P. So I'm going to do an example with you. Some of this lecture notes I'm going to skip. And if I'm skipping it, it's either because it's not something you're going to be tested on or seeing on the homework, or just because there's a lot of examples in this and I can, reinforce something in a different example. So skip example 2, and I want to go to example 3. It says, write the negation of the given proposition and then state the truth value of the original proposition and its negation. So let's just look at the original proposition given to you. Look at A. It says the Beatles were not a German band. Okay, and we want to write the negation of that. What would the negation of that be? Remember, negation means opposite. Negation is the opposite of the original proposition. So the opposite of the Beatles were not a German band is the Beatles were a German band. Or are. And then the second part of this says, state the truth value of the original proposition and its negation. Remember what truth value means. Any proposition, look above, has two possibilities. It could either be true or false. So in the original proposition, I'm going to do this with a different color. Is this original statement true or false? Just going to put true right next to that. The original proposition is true. And then this negation, they also want me to state the truth value. The Beatles were a German band. That is false. So I'm going to put false right here. This is the original proposition. Earth is the center of the universe. Earth is not the center of the universe. Okay, and then we want to state the truth values for each. So the original proposition, is that true or false? Earth is the center of the universe. And then next, Earth is not the center of the universe. True. Very good. Okay. Let's look at this next example. It says, explain the meaning of the given statement, then answer the question that follows. So the idea here that I'm addressing in example 4, it's about double negatives. double negatives, and I'm going to show you guys that. So it says, Sarah did not decline the offer to go to dinner. Did Sarah go to dinner? Yes. This is just an exercise used to test the reading comprehension. There's a double negative that's happening here. Did not and decline. This is designed to kind of confuse some people. Did not decline means that she did go to dinner. It's just that the double negative confuses some. So did Sarah go to dinner? Yes, Sarah did go to dinner. Look at the next one. Sue disavows association with any organization that opposes planting new trees in the park. Does Sue want new trees planted in the park? What is the double negative here?
Disavows and then opposes.
Right. Disavows and opposes. So when they say Sue disavows association, she's saying she doesn't want any association, right? With any organization that opposes, again, another negative. So she wants to break any association. She doesn't want association with any organization that doesn't want new trees planted, which means she is for new trees being planted in the park. She wants that. So the answer to this is Sue wants new trees planted in the park. We're going to get into truth tables. Before I do that, I just need to show you guys some symbols. And so I'm going to highlight what you need to know, and that's negation. We talked about that. Negation means not. The symbol for negation is this like squiggly line. You do have to know that. And I'm going to write the rules for all these things, and just bear with me, copy them, and then I'll explain them in a second when we actually do a truth table. So the rule for negation is if I have a proposition P, right, just a simple statement, complete sentence, the negation would be the opposite of P. Now, and remember we talked about and as it connects two or more propositions. It's called a logical connector. You don't need to know the name logical connector, but and connects propositions. And the symbol for and is an upside down V. And this is the rule for and. Remember, I said you have, in this case, two propositions. So let's call them P and Q. So I'm going to say P and Q is true only if both P and Q are true. So I'll explain that in more detail in this next exercise, but for now, just write that down. So you do need to know what and the symbol looks like. You don't need to know that it's called a conjunction. I'm not going to test you on that specifically, but you just need to know the symbol for and the rule. Okay, next is or. Again, you don't need to know inclusive, exclusive, or that it's called a disjunction. I just want you to know or, and the symbol for or is a V. And here is the rule for or. This is true if either P or Q is true. And it is false if P and Q are false. Okay, and then the last one we're going to discuss. Sorry, guys, I'm trying to highlight that I want you to know all these rules. Okay, the last thing is if then. The symbol for if then, again, you have two propositions, P and Q, would be this, with an arrow to Q. This reads if P then Q. This arrow kind of means then. And so let's look at the rule for that. This if P then Q, this is true all the time. Except when P is true and Q is false. So it's true all the time, except when the P is Q and when the P is true and the Q is false. And this is called a conditional. You'll hear me say that. So let's look below. This is a truth table. Okay, so it looks like I have two propositions. Look at the first two columns. I have P and a Q. Now, I kind of constructed this table for you. See below, there's 4 rows. A truth table is the all possible values, all possible truth values that could occur with P and Q. Now, how do I determine how many possible values there are? This is how you do that. You do 2 and you raise it to however many propositions you have. So you see here, I have P and Q, that's 2 propositions. So I'm raising 2 to the second power. This big 2 is called a base, right? And this small 2 is called an exponent. What does 2 to the second power mean? Is 4. And that's how I've determined, okay, there's going to be 4 sets of possibilities here for P and Q. So again, this 2 is based off of each proposition, like P, for example. There's only 2 possibilities. It can either be true or false. That's true for any statement, right? It's either true or false. That's where this big 2 comes in. Now, the exponent 2 is because there is 2 propositions, P and Q. That's how I determine 2 to the second power, 4. Now, this is the easiest way to figure out all the possibilities. What I do is I put the first half true and the last half false. So the first half here would be the first 2. Put the first 2 true and the last 2 false. And then for Q, alternate true, false. So that's true, false, true, false. So let's take a look at what I just did. I just listed all the possibilities, which is only 4, we've determined that, for true, false with the PQ scenario with 2 propositions. They can both be true. The first could be true, the second could be false. The first could be false, the second could be true, or they're both false. Those are all the possibilities. Now, let's look at this next column. What is this? What does that mean? I'm going to say not P, right? Not P. So how do I find this? I look at the P column, look at each row, and do the opposite. So the opposite of true is false. The opposite of true, looking at the second row on the P column, is false. The opposite of false is true. The opposite of false is true. So look at this. This says not Q. So again, that symbol means not, right? Negation. So look at the Q column and do the opposites. So the opposite of true is false. The opposite of false is true. The opposite of true is false. The opposite of false is true. Look at the next column. That upside down V is and. So yes, this is an and. So you see here, I'm dealing with two propositions, P and Q, and I'm doing P and Q. So this is where I'm going to take you back to the rules that we wrote. Look at this rule, the table here, the second one. It says P and Q, meaning the statement P and Q is true only if both P and Q are true, meaning P has to individually be true and Q has to individually be true. And if they're both true, then the statement P and Q is true. So let's look at that. Let's focus on the first two columns of this table. We're going to go row by row. P is true and Q is true. So the statement P and Q would be true because they're both true, right? What about the next one? P is true and Q is false. False, correct. They both have to be true in order for the and statement to be true. Look at the next one. P is false, Q is true. So what is P and Q? False, good. Again, they both have to be true individually for the statement to be true. P is false and Q is false. It's a very strict rule, right? If it's an and, then both individually have to be true for it to be true. And then let's look at the next one. What does that read? Or. This says P or Q. So let's look at the rule for or. An or statement is true if either P or Q is true. And it's false if P and Q are both false. So in other words, if we're looking at P and Q, if either one of them is true, then the or statement is automatically true. So look at the first one. P is true and Q is true. True, good. P is true and Q is false in the second row. So P or Q is, at least it's saying just one of them has to be true. And then the statement or is true. P is false and Q is true. So P or Q is true. Good. Last one. P is false and Q is false. So P or Q is very good. False. So for ors, it's a lot looser. It's not as strict as the and. Remember with and, both P and Q have to be true. They both have to be true. Otherwise, it's false. With ors, I just need one of them to be true. And then the whole statement is true. We're almost done with the truth table. Let's look at the last column. Good. This is the if then statement. And so let's look at what happens here. Look at the rule. If P then Q is true all the time, except when P is true and Q is false. So these if thens, I found that they're a little bit harder to understand. So I'm actually going to give you an example on the side here. You can write it down if you want to, of an if then statement so that it kind of makes sense as we go through these scenarios. So here's an example of an if then. If I am elected, then the minimum wage will increase. Okay, that's an example of like an if-then statement. If I am elected, then the minimum wage will increase. So I consider this, if I am elected, like my P, then the minimum wage will increase. I'll kind of consider that my Q. So it's always true. That's what this is saying. This statement is always true except when P is true and Q is false. So let's run through these scenarios. So if P is true and Q is true, what that means in this example is the person was elected and therefore the minimum wage will increase. This statement should be true because whatever the person promised, happened. They got elected and what they promised, the minimum wage will increase, occurred. So this statement is true. Look at the next one. P is true and Q is false. So the person got elected. That's what P is true means. But despite being elected, the minimum wage did not increase, right? That did not happen. That's what Q being false means. This is a scenario where the promise did not occur. He did not or she did not make good on the promise. So this is a false. Next one, P is false and Q is true. So if I am elected, now we're saying that's false. So what that means is the person did not get elected, but Q is true. The minimum wage still increased even though the person did not get elected. We call this true because at the end of the day, what do we care about? The fact that the minimum wage still increased. The promise was still came to pass. So this is why this is a true statement. We only consider if-then statements false if the promise does not happen and P occurred. The person got elected, but the minimum wage still did not increase. That's the only scenario where this is false. And look at the last one. P is false and Q is false. So what that's saying in terms of this example is the person did not get elected and therefore the minimum wage did not increase. Well, that tends to track with what's being said here, right? This statement says only if the person is elected, the minimum wage will increase. So I could expect that if the person doesn't get elected, the minimum wage will not increase. So this statement is true. So let's look at the next few examples. It says find the truth value. So we're used to right now just looking at a truth table, finding all the possibilities. But this is another way we could do it. Here we have, I know these don't look like complete sentences, but in math, equations can be considered propositions. So I'm looking at these and I'm seeing an and in between. But remember, each proposition can either be true or false. But what is 3 + 2 = 5? Is that true or false? True. So I'm going to translate this basically is what I'm saying. This means true. And the symbol for and, remember, is a backwards V. And then let's look at this proposition. 6 + 4 = 8. So what's the answer to this? True and false. Very good. Remember, for an and statement, they both have to be true in order for your final answer to be true. So that is how I found this. The truth value to this whole thing is false. Okay, let's look at B. Can we do this one? So 3 + 2 = 5. True. And here I have an or, which is a V symbol. And then 6 + 4 = 8. False. And what is the answer to true or false? Good. At least one of them has to be true for it to be true. So that is my answer. We have time, so let's look at C and D. Now, this is a proposition written in words, right? So it says Emily Dickinson was a poet and Kanye West is a major league pitcher. So these are two separate propositions connected by the word and. So I'm going to assign a truth value to this. Emily Dickinson was a poet. That is true. This person is a poet or was a poet. And is the backwards V. Kanye West is a major league pitcher. Is that true or false? False. And what is the true and false result? False. Remember, for and, they both have to be true. Good. Look at the last one. Cars swim or dolphins fly. So these are two separate propositions connected by or. So cars swim, is that true or false? False. And then or, so that's a V. Dolphins fly, is that true or false? Yes. So a false and false would be false. Good. So then let's look at a bigger truth table. In example 6, it says, write the statement in symbolic form, and then we're going to construct a truth table. So this is the sentence, I am hungry and I want to eat a healthy lunch, or I want to eat in a hurry. So this is a one sentence, but it has, see how I wrote PQR? It has 3 different propositions. And you can tell what the propositions are because you'll see the connectors. So let me show you that. You see where it says and? That means I'm connecting 2 things. So the first one is I'm hungry, which I'm going to call that P. I am hungry. Followed by the next one, which is I want to eat a healthy lunch. That's the next proposition. So I'm going to write that here. I want to eat a healthy lunch. And then you see the next thing, the connector is a or. What's the last proposition? I want to eat in a hurry. Now, this is important. It says, write it symbolically. So I'm going to read this sentence again, and I'm going to try to write it with the variables and the symbols. I am hungry. We said I am hungry is P. And means, this is the symbol, like the backwards V. I want to eat a healthy lunch. We called that Q. And then there's a comma. And so I kind of skipped the portion where this was stated. But if there's a comma on one side, then you group it together with parentheses. So you see how the comma's here? I'm going to group this together with the parentheses. And then I'm going to follow the rest. Or is a V, right? That's the symbol. I want to eat in a hurry. We called that R. And so this is how we've translated this sentence symbolically. Okay. So when I create this truth table, the propositions are P, Q, and R. And again, I have to figure out all the possibilities. That's what a truth table is. It's all the possible options for truth values for these 3 propositions combined. So remember how I figured out what number, like meaning how many options I have? I said you always have a 2, and that 2 represents there's only 2 truth values, true or false. And then you raise it to how many propositions you have. In this case, I have 3 propositions, P, Q, and R. So I would be doing 2 to the 3rd power. And what is 2 to the 3rd power? Good. I'm just going to write that here, 2 times 2 times 2, which is 8, correct. And so if you see here, that's why I have 8 rows below. And then remember, there was a shortcut I showed you guys for how to figure out all the possibilities without doing it by hand, taking time to do it. What I did with P is I did the first half true and the last half false. So because I have 8 now, the first half would be the first 4 would be true, and the last 4 would be false. That's your first step. And then remember, when I only had P and Q, what I would do is alternate true, false, right? But because I have an R after, I cannot do PQ, PQ, P. I'm sorry, I can't do true, false, true, false, true, false. I'm going to double alternate, which means true, true, false, false, true, true, false, false. And then on this next column, I'll alternate true, false. This is just a way that I found that is a very quick way of capturing all the possibilities here. The next thing I'm going to do now is the goal is to get this, right? I'm trying to achieve this. I can't just go and do this all at one step. Similar to like order of operations. Remember order of operations when you were doing algebra? They always tell you do the parentheses first, right? So that's what I'm going to do. I'm going to figure out what is in the parentheses, meaning what is the answer to P and Q for all of these options. So let's do that. P and Q only focus on the first two columns. So true and true would be what? True. True and true again. True. True and false would be false. Remember, for and, they both have to be true. True and false is false. False and true, again, is false. They both have to be true. False and true is false. False and false is false. And finally, again, false and false is false. Now I can kind of complete this, what I'm looking for here. So I'm going to write the whole thing out. This is what I've been trying to find. And I want you to check this out. I just found out what's in the parentheses, right? That's basically what I wrote. I'm going to try to highlight that. That's basically what I wrote there. Now I'm just trying to use this column and attach it to or R and complete it. So this is what I mean by that. I'm going to write it out. P and Q for the first scenario, we just found that is true, right? Now I want to do or, and let's look at the R column now. The first scenario is true. What is true or true equal? True. We're looking at the P and Q column, and we're looking at the R column, and we're combining them with an or, and we're getting our answer of true for the first one. So let's look at the second one. The P and Q, we found that is true, or R is false. What is true or false? True or false is true, yes. Look at the next one. False or true. R is true. False or true is, would be true. False, P and Q is false, or false. What would false or false be? False or false is false. And then next, false or true would be what? Good, true. At least just one of them has to be true for it to be true. Next, false or false would be false or true would be. Last one, false or false. What would that be? False. Good. These that I'm highlighting are the answers. There's not one answer because remember, a truth table is giving you all the possibilities. So These are all my final possibilities. Let's look at the next example. Now it says determine the truth value of the statement if. So this is what I want to figure out, right? Right here. And it's telling me you don't have to guess now. P is going to be assigned a true value. Q is a false value. R is a true value. So there's no more guessing. I don't have to do a big truth table here. I really just have to substitute these truth values in and then figure out what's my answer. So let's do that here. I'm going to put equals. In my parentheses, actually, sorry guys, I want to do it up here so I have room to write down. So I'm going to do this over here. P, they say, is true. So I'm going to put true. I'm going to keep the symbol for and. And if Q is false, what is the negation? That's what that line means, right? Squiggly line. What is the negation of false? True. Okay. Or, and then it says R. R is a true, right? So I've just kind of substituted the values in there. Now, just like order of operations, let's do the parentheses first. What would true and true be? True, good. And then I'm going to add on the rest, or true, right? So what is true or true? True. And that would be my final answer. Look at this one. We're going to do the same thing. So the first thing I'm going to do is I'm going to replace these variables, right, with their truth value. They're giving them to me. This, what I'm highlighting here is the actual problem, right? They're giving me the truth values for those variables. So we're just going to plug them in. Well, first it says in the parentheses, negation of R. Good. R is true, but the negation of that would be false. Very good. And, okay, what's the negation of Q? Q is true, but the opposite of true is false. And then I'm going to do the next parentheses there. The negation of R would be what? False. R is true. The opposite of true is false. Or, and what's the negation of P? True. Good. Any questions on how I kind of did that? So now we're going to do the parentheses. I have two sets of parentheses, so I want to find a value for each. So the first parenthesis says false and false. And what would that be? Good. I'm going to keep this and that's in between there. And let's do the next parentheses. This says false or true. What would that be? Good. And now I can answer the question. It says false and true. What would that answer be? Well, this seems like a little out of nowhere, but you do have some homework questions about this, so I just wanted to go over this. So this is about obtaining a loan. So we want to identify which applicants would qualify for the loan, and I'm going to read below what's the qualification. So it says to qualify for a loan, 45,000, to qualify for a loan of 45,000, an applicant must have a gross income of 30,000 if they're single, 50,000 combined if married, and assets of at least 10,000. Okay, so that's the qualification. So what we want to do now is read these three people's scenarios and see if they qualify for the loan. So the first one, Mr. Argento married with 2 children, earns 37,000, and Mrs. Argento earns 15,000 at a part-time job. The Argentos have assets of 25,000. Would they qualify for the loan? No? Okay. I'm just going to put a check mark. They do qualify for the loan. As a married couple, they make 50,000 at least, and they have over 10,000 in assets. Let's look at the next one. So it says Miss McVeigh is single and has assets of 19,000, and she works in a store and earns 25,000. Would she qualify? I'm just going to circle this. You need to make at least 30,000 if you're single. So this, I'm going to put an X, does not qualify. Good. She does have enough assets, but it's just the income. Okay, let's look at the last one. Mr. Seward earns 24,000 and Miss Fox, his wife, earns 28,000. Their assets total 8,000. Would they qualify? Oh, good. Why wouldn't they qualify?
They don't have enough assets.
Mm-hmm. Yeah. Combined, their income is greater than 50,000, so that's okay. But their assets have to be at least 10,000. And in this case, it's not, so they do not qualify. So what if-then statements are called conditionals, right? These are the if-then statements. And it's P then Q. So the P is referred to often as your first proposition. This is like your premise. And the Q is your conclusion. You can look at it like that. So here's two if-then statements, and it just says label the premise and conclusion. So it says, if Paris is in France, then New York is in America. It's in this structure of if-then. So Paris is in France, that would be your premise. And the conclusion, New York is in America. That's just the structure of these. And so we look at the next one. If Paris is in France, this again, the first part of this is my premise. Then New York is in China. That would be my conclusion. Again, the statement doesn't make sense, but that's not the point. It's just that the structure of a conditional statement. The first proposition is your premise. The second is your conclusion. Now I want to skip C and D because we just kind of did examples like that. So you guys don't, if I'm skipping it, you guys don't have to do it. And let's look at E. So it says both simple statements are false. And so I've already kind of labeled the statements. I've called this first one P, which is Mike spoke at the teachers' conference. We're saying it's false. So on the top here, I'm just going to say P is false. And then the next statement, I'm calling it Q. Mike received the Outstanding Teacher Award. That's also false. So I'm going to say the proposition Q is false. So P is false and Q is false. Now it says determine the truth value. So it says if Mike did not receive the Outstanding Teacher Award, then Mike spoke at the teachers' conference. So I need to first translate this, and then I'll figure out the truth value for it. So let's practice translating this. And when I say translate, it means use the appropriate symbols and variables. So the first one is, this is a if-then statement. So I know I'm going to have to put the arrow symbol for if-then. But first, let's do this. Mike did not receive the Outstanding Teacher Award. Is that associated with P or F? Look at the two statements of P and F. Which one talks about the Outstanding Teacher Award? Q. But it's not exactly Q, right? Because it said Mike did not receive. Q says he received it. So how can I make that adjustment? What would I do? Delete the Q. Good. It says not. Then, remember, this is where I put the symbol for the if-then. Okay, and then it says Mike spoke at the teachers' conference. What would symbolize that? P. That is exactly P. Now what I'm going to do is I'm going to assign the truth values to them because I actually have them. So what is the negation of Q? What would that be? True, yeah, because Q is false, right? So the opposite of that is true. Then, and then P is false. Okay, so this is that if-then. And so remember the example I gave? if I am elected, so the person is true, they did get elected, then the minimum wage will increase. But in this scenario, false means the minimum wage did not increase. So what would the result be? Does that make sense, class, how we translated that? Any questions so far? Okay. For the next example, I'm just gonna do A and B. I think we will be able to understand the idea with A and B. So these phrases or statements, I should say, that I'm about to read are not phrased correctly. We want to rephrase them into conditional statements in the form if then. So look at the first one. It says a Bostonian life in Massachusetts. How can I restructure that to be a if then statement? A Bostonian life in Massachusetts. Well, what's the relationship between Boston and Massachusetts? Boston is in Massachusetts, right? So maybe I could say, if a person lives in Boston, then they live in Massachusetts. That would be restructuring this as an if then statement. So I'm going to write that here. If a person lives in Boston, then they live in Massachusetts. Does that being a medical doctor requires knowing anatomy? How can I structure that as a if then? Medical doctor, then you know anatomy. If you are a medical doctor, then you know anatomy. Structuring sentences so they're more in that conditional format of if then. We're going to skip example 12 and we're going to move on to the last topic, which is conditional. We know P, if P, then Q, but I want to talk about other types of statements. So conditional is just the original proposition, right? I'm just going to say this is our original I'll just say original. This is the original. Now, converse. Converse means I'm going to flip the P and Q. So it's all if then statements. Conditional means I'm dealing with if then statements. But if it's a converse, then it's Q, then P. I've flipped the order of the original. Inverse means I'm going to negate the original. So it's negation P, then negation Q. So I'm going to keep the order and then negate each side. Okay, so converse means I'm going to flip them. So if Q, then P. Inverse means I'm going to keep the order, but I'm just going to negate it. So not P, then not Q. And finally, contrapositive means I'm going to, in terms of the original, right? I'm going to flip it. So it kind of looks like the converse, but then I'm going to negate each side. So this is flip order and then negate each side. Okay, so these are different kinds of if-then statements. So I'm going to give you an if-then statement, and I'm going to show you what each looks like, the converse, inverse, and the contrapositive. So look at the normal, original conditional statement. If it is raining, then I will bring an umbrella to work. So if it is raining, that's like my P, then I will bring an umbrella to work. That's my Q. That's the original. Let's write out in words the converse. Look at what a converse means. I'm going to flip the P and Q. How would we state that? So I'm going to write it like that. You always keep the if-then words there, right? You're just changing or flipping the Q and the P. So if I bring an umbrella to work, if I bring an umbrella to work, comma, then it is raining. So I just flipped the P and Q. That's converse. Let's look at inverse. Inverse means you keep the original order, but we just negate each side. So if it is not raining, then I will not bring an umbrella to work. You're just negating but keeping the order. Oops. If it is not raining, then I will not bring an umbrella to work. Good. And then the last one, contrapositive. Contrapositive means you flip the order, right? If I have the original, I'm going to flip it. And so this, sometimes for contrapositive, remember it's kind of like based off of the converse. The converse, you flip it. And now I just negate it. So sometimes for me, it's easier to look at the converse and then just negate it. If I do not bring an umbrella to work, then it is not raining.